Alright, continuing off with our review, we'll start with number 18. There's 2 more pages left. That's crammed full of the rest of the questions. Alright, 18 looks like a plug and chug. We're looking for current using power, and we're also giving voltage. P equals IV is a simple equation to use. Don't worry, you'll be given the reference table. Alright, this is our power. Looking for current, we have 3.6 volt battery, 0.064 divided by 3.6. I should be this number. Oopsies. Should be choice A. Alright. Number 19. Electrical appliance draws 9 amps of current when connected to a 120 volt source of potential difference. What is the total amount of power dissipated by this appliance? Alright, we have current and voltage, same equation, plug and chug. You guys go ahead and do that while I do the work. 9 amps, 120 volts, 9 times 120 should give you approximately this number. Not exactly this number, but it's approximate. Choice D. Number 20. Circuit contains a variable resistor connected to a source of constant voltage. As the resistance of the variable resistor is increased, the power dissipated in the circuit will what happen? Alright, power. Something that relates power, voltage, and resistance. This equation. So if the resistance is increased and power, we're looking at power. If we actually increase our resistance, then our power should go down as a result. If you think about it, more resistance, less power drawn, less current, and such. So A decreases. Number 21. Circuit diagram below, 2 4-ohm resistors are connected to a 16-volt battery as shown. The rate at which electrical energy is expended in the circuit is, alright, P is equal to V squared over R. So we're looking at the entire circuit as a whole. That means we gotta find REQ. This is series, so this is simple. 4 plus 4 is 8 ohms. Okay? We're looking for P. P is 16. And we square that over 8. 16 squared is, it's approximately, let me get a calculator. Alright, it's equal to 256 divided by 8, that is 32 watts. Choice C. Alright? And let's move the page down a bit. Alright, we're on number 22. The total amount of electrical energy used by a 315 watt television during 30 minutes of operation. So energy E is equal to power times time. Energy is what we're looking for. Our power is 315 watts. And we have 30 minutes. So we have to convert that to seconds. 30 minutes times 60 seconds should get us about 1800 seconds. 315 times 1800 will give us approximately this number. 5.67 times 10 to the 5th joules. Choice A. Number 23. What combination of units can be used to express electrical energy? Okay. Electrical energy. Let's see. Let's start with this. This is equal watts times seconds. P is equal to IV. P, which is equal to amps times volt. Alright. I is equal to Q over T, which is equal to charge, Coulomb, over seconds. Alright, so let's plug these back in. We're going to take this, put it over here, which is equal to amps. Alright, so power is equal to Coulomb times volt over second. And we're going to take this, P, and put it over here. Alright, so E is now equal to Coulomb times volt over a second times another second. These 2 seconds cancel out, and we're just left with Coulomb times volt, and that is choice C. Choice C. Okay, everyone, I'm busting out the purple. Number 24. We're looking for current, given we have energy, we have voltage, and we have time. All we have here a 2-step problem. Alright. P is equal to E over T. We're going to use that power to solve for current, because right here. So I here is equal to P over V, which is equal to E over T divided by V. So when we plug these things in, we should get I is approximately 15 amps, and that is choice B. Okay? 25. How much total energy is dissipated in 10 seconds in a 4 ohm resistor with a current of 0.5 amps? Okay. Energy is equal to P times T. Using I and R together, we get I squared R for P times T. .5 squared times 4 times 10 seconds, and we get, oopsies, we should get, whoa, why isn't it erasing? Oh well. Okay, scribble that out. We should get 10 joules. Choice C. 26. The electron volt is a unit of, well, you guys don't need to know that, but for your information right now, it's energy. We don't get into that till later on. Choice A. Energy. Okay, let's go back to purple. Number 27. Which object will have the greatest change in electrical energy? Alright. Wow, we got a trick question here. This question kind of utilizes, well, this equation, where work is energy. It can also stand for electrical energy. Okay? So we're looking for the greatest electrical energy. When we multiply voltage in Q, we can get work or the electrical energy. If we look at each of these choices, if you take your voltage and you multiply it by the given charge, then you can find the work. So you got to figure out which one's the greatest, and that's choice D. If you look through each of these choices, you'll see that choice D has the greatest work. Okay, moving on. And now we have arrived at the final page with the short answer questions. Please be reminded, when you answer these short answer questions, you must include units. Alright? Otherwise, I won't give you full credit. Alright. And it says here to use the reference table. The reference table is your best friend. Treat it well. Alright. Oh look, it's asking us to draw a diagram. So here you guys get to practice drawing those diagrams. So we have 5 ohm resistor, 10 ohm resistor, 15 ohm resistor connected in parallel. Parallel meaning we need to have branches with the battery. So let's draw this sucker out. This is our battery. Here we're going to have 3 resistors in parallel with each other. And they told us that the current through the 5 ohm resistor is 2.4 amps. So first let's label these. 10 ohms and then 15 ohms. Alright, let's put an ammeter here to show that we're having a current reading. Ammeters shown with A. Don't forget, let's put there 2.4 amps. Alright? And that's it. That's our diagram for part A. Part B, calculate the amount of electrical energy expended in the 5 ohm resistor in 2 minutes. Alright. Our equation here for 29 is that E is equal to P times T. You could break this down by finding P. Using R is going to be I squared R times T. This I squared R stands for P. You'll find it in the reference table, 3 different ways to express P. So here our electrical energy is going to equal, what's our current? 2.4 amps. Don't forget units, guys. Resistance is 5 ohms. 2 minutes, which is the same as 120 seconds. Plug and chug. You're going to get 3,456 joules. If your work looks just like this with the 3-step method, equation, substitution with units, and answer with units, then you'll get the full credit. Alright? Number 30. 20 ohm resistors added to the circuit in parallel with the other resistors. Describe the effect the addition of this resistor has on the amount of electrical energy expended in the 5 ohm resistor in 2 minutes. Alright. So let's say here, I'm going to put in this drawing right here. We're going to add another resistor here, 20 ohms. Right? And we're going to figure out what kind of effect does it have on the other branch. So what we're going to see here is that whatever happens in the other branches doesn't really affect what happens to the other branches. What it only affects is the overall circuit. So I'm going to write a note here. Adding branches affects the whole circuit. But not the other branches. So whatever goes on in the 5 ohm branch right here, whatever goes on in this branch, is still going to go on the same way. So energy expended stays the same. Stays the same. Alright? If you think back to some of those switch examples we worked on earlier in class, you'll see the same idea happen. Alright, now let's move on to the next part. Now we're on numbers 31 to 33 based on this. So we want to complete the diagram above to show two resistors connected in parallel between points A and B. So we got 15 ohms and 30 ohms connected in parallel. So the way to show this is like this. Just like that. We have 15 ohms on top and then 30 ohms on the bottom. Either way is acceptable. Alright, next, number 32, determine the potential difference across R1. So, remember, parallel branches, parallel circuits. V stays same between branches, okay? So for number 32, still 90. The 90 volts that comes out through the battery still separates into 90 volts in each branch, alright? Then we gotta calculate the current in R1. We know our voltage is still 90. We're looking for current I and R, resistance R. R1 is 15 ohms. 90 divided by 15, I is now 6 amps. 6 amps. So if you show your work just like this, you'll get full credit. And that is it, folks. That is it. Hope this helps. Once again, if you want your own paper copy of this review question packet, check Pupil Path for the attachments to Circuits Test 1 or 2. Both versions have the same packet attached to it. Alright, that's it. See ya. Bye, Felicia.